Unit 3. And Unit 3 is on probability distributions. And as you may recall, we have several of these different types. But despite the fact that we have multiple different types of both discrete and continuous probability distributions, we will be focusing on specific ones, as you will see in this unit. So, in the previous unit, we calculated probabilities. When we have a set of probabilities that form to make a probability distribution, we have some interesting properties to discuss. One of the variety of discrete probability distributions we will specifically focus on, the binomial and Poisson probability distributions. Within these topics, we will apply these to the general biostatistics field and solve various applications thereof. But discrete probability distributions are not the only type of probability distributions. There are also continuous probability distributions that are an interesting advancement of probabilities. And again, there are multiple forms of continuous probability distributions. We're only going to focus on two different types. The most important continuous probability distribution is the standard normal distribution. We will apply the normal distribution to various real-life applications within biostatistics. Then these applications will allow us to form sampling distributions as estimators, utilize the central limit theorem to apply the normal distribution in most situations, and assess normality. One important application of the normal distribution is to approximate the binomial distribution, essentially connecting the continuous probability distribution to the discrete probability distribution. And it should also be noted that the only other continuous distribution that we're studying, other than the normal distribution, is the uniform probability distribution. But we'll look more into that as we get to the material. The objectives for this unit are to describe, and I should probably note, we do note the various normal distributions and various pictures of how these change and based upon what we do. The objectives, though, are to describe the properties and interpret discrete probability distributions, including the binomial and Poisson distributions, calculate the expected value, describe and interpret continuous probability distributions, including the uniform normal and standard normal distributions, describe sampling distributions of statistics, which are used as estimators of the associated parameters, although we'll be doing more with that in a later unit as well. Describe and interpret the central limit theorem, and then apply techniques to determine if a set of data has the requirements for a normal distribution to be satisfied. So from this unit, this is based on chapters 5 and 6 from our textbook. So discrete probability distributions and normal probability distributions. We have various optional ebook resources and videos that will be different than my own and my SAS videos. Unit 3 is on a sampling distribution of a dataset. So if we does not have it on there, so I'll just keep it on here then. We want to choose a dataset from the data files folder down here and narrow that dataset down to 50 entries. We want to ask at least 5 questions surrounding the dataset for your classmates to answer, and then you respond to them on whether or not they are correct. And in response to your peers, answer the 5 questions your classmate provided based on the chosen dataset. And again, I know there's only 2 of you in this class, so that will only have to be happening between the 2 of you. And then, of course, any questions I then ask. The data files are right here, which I also have linked on the main announcement on the page. But you would have all of them linked in a format that could easily be used within SAS, which you could tell when you... Okay, it doesn't give me the description of it. Well, these are in a format that can be usable in SAS. So you can find those on there. The Unit 3 problem set is also located on here. This being due that Sunday here of the week. And as you can see, it asks a whole bunch of variety of data and what these different parts mean, and interpreting them based upon what we have for the various measurements here. As you can see, there's a total of 12 unique questions, but there are multiple parts to each one. And once again, which is not located on here, but I'll just say it anyway, you should continue to work on Project 1, since, just to warn all of you in advance, Project 1 is indeed due here within Unit 4, down here near the end of that. So, if you are not already working on that, I do highly suggest doing so as soon as possible. But, on that note, let me know if you have any questions or concerns. I'll be more than happy to help. Thank you.